guys to today's class on practical physics. We want to look into experiment on rectangular block prism. We have posted a video on rectangular block prism. That is the first part of it. I want to see another part of a rectangular block prism experiment to discuss. Welcome guys to today's class on practical physics. In this video, we want to discuss experiment on rectangular block prism. We have posted the first part of it. This is the second part of rectangular block prism, where we have a radius, a circle, and all have you on the experiment. So we want to see how we can perform this experiment without touching apparatus. And that means we want to use formula method to appreciate it, so that if you are given such experiment where there is no light or where there is darkness, you will be able to perform it because you know the formula method. Now, first thing to note why using formula method to solve any question on experiment or to perform experiment on any aspect of practical physics, what you do is, for this question now, we have to note what our refractive index means. Yes, it's coming from light. This light ray is coming from air and it's entering the glass and going. So refraction tends to exist because there is change of medium from air to glass to air. So from air to glass, it will reflect toward the normal, then to air, it will reflect away from the normal. This is the pin. This is the traces of the light ray. Yes, light ray, it's moving this way. That is the direction of the light ray. This is rectangular block prism. And look at a circle made on it with a radius. Now, what we do first is that we have to recall Snell's law, which says that the refractive index is sine I all over sine R. We have to note this. We have to also recall our SOHCAHTOA. SOHCAHTOA, that is sine equal to opposite over hypotenuse cos, adjacent over hypotenuse tan, opposite over adjacent. We have to recall that. Now, what we have to do is, first, get this diagram out, bring it out. That means this is my radius, this is my A, this is my perpendicular line. So this is my A, my R, and my I. Then the next one is to bring out this. So this is your R. That is, at this point, this is your refraction. This is your radius. This is your radius. Then this is your B. Now, the implication is that this is your radius, because we say radius is the distance from the center of a circle to any point on the circumference. From the center to any point. So they will have the same word, radius. But their A and B will now vary, and their I and their R, that is the angle of refraction, will now vary. So for here, it means that the R will be constant, but the I and R will not be constant, and the A and B will not be constant. So for this part, the formula we use is, we are looking for A, and we have opposite, we have hypotenuse, we have angle. We say sine I is equals to what? Opposite over hypotenuse, A over R. Therefore, A, which you are looking for, equal to R sine I. That is the formula we'll be using for this. We say A equal to R sine I. Then for this one, this is B, this is R. So we now say sine angle of refraction is equals to opposite over hypotenuse. Therefore, B will be equals to capital R sine R. So B equal to capital R sine R. So that is the formula we are to use and put it here. After noting this, your formulas you have to use to get your A and your B. Next thing to note is that the refractive index has a range. The range begins from 1.46 to what? 1.54. So that means if we finish solving, we'll still fall at this. But before then, we need to pick a value here that we are to use so that we can put it in the calculation. Now, I can pick 1.48. 1.48 falls inside here. Why I am picking this value is we need to know the value of R because we need R here. So that means from here, we say that sine R is equals to sine I all over refractive index. Therefore, R will be equal to sine inverse bracket sine I over refractive index. So we have another formula, R equal to sine inverse bracket sine I over refractive index. So these are the three formulas we need for this experiment to be performed without touching apparatus. Let's see how to make it. So let's get our A first. Now this is the refractive index we are using. Refractive index is equal to 1.48. Radius is equal to 5 cm. So we'll be using capital R to be 5 cm. You can put any radius you want. You can use 1, 2, 3, 4, 5, 6, 7, any number you want. But that number will be unique. You will use it throughout. So, having noted that, now to get our A, we say R is 5 sine what? I is 30, that is the first value. 5 sine 30, that is 2.50. 5 sine 40, 3.21. 5 sine 50, 3.83. 5 sine 60, 4.33. 5 sine 70, 4.70 approximately. That is to two different places. Now, before you get your B, you need to know what your R is. Your R will be equal to, for the first one, equals to R is equal to sine inverse bracket sine I over sine 30 over 1.48. Because you say let the refractive index be 1.48. So we now say shift sine bracket sine 30 divided by 1.48. So we'll be having individual value of R. The first one to be 19.75. Let's see the second one. This is for 30, the first one. For the second one, We change 30 to 40. 25.74. We change 40 to 50. 31.17. We change 50 to 60. 35.81. We change 60 to 70. 39.41. So these are the values of your angle of refraction. These are the values. We will now put it here. For the first one, R sine R, that is 5 sine 19.75. We have our B to be 1.69. 5 sine 25.74. 2.17 sine 31.17. 2.59. 5 sine 35.81. 2.93. 5 sine 39.41. 3.17. So we have gotten our answer. Look at the values we use to get it. We have gotten our A, our B, our I, our R, everything. Remember that the radius we use depends on what you want to use. That is about how to make your table. In the next video, you will see how we can plot the graph of A against B, get the slope, get the error in the slope, and state what physical quantity A represents. We have gotten our radius from the video before now. I want to see how to plot the graph. Now, before you do the graph plotting, please note that here you have to put your date, then say a graph of A in cm against what? B in cm. So after you put your date, say graph of A in cm against what? B in cm. Very important. Then next thing is to locate your Cartesian axis. Okay, I will just put my Cartesian axis. I just decide to skip 1 in case of what I'm to write. Let me see what to write. What determines where to put your Cartesian axis depends on some factor. If you see that if you put your Cartesian axis here and here, and writing figures here will make it look congested, you will see that you have to put it in the next line so that you will see what you are writing. That can be a factor to be considered. So what you do is, if you want to learn more about what we are doing in graph plotting, touch Daniel how to choose appropriate scale in graph plotting. You will see my video on that and learn more about it. Now here is B in cm. Once you write the quantity, you put the unit. A in cm. The next thing you have to do is you ask yourself, do they specify from the origin? If they did not, it means you can start from the origin, or you cannot. You may decide not to start from the origin. I personally will decide not to start from the origin. The reason being that if I start from origin, from 0 to 2.5 is far, and 2.5 you are just covering the distance of 2.5 and 4.7. So from 0 to 2.5, you now see that there will be vacancy between 0 and 2.5 because you start your plotting from 2.5. So because of that, look at what I will do. For this A axis, what I will do is, it is called vertical. I will say, let me start from what? 2 here. Let me start from 2. Then for this B, the horizontal, let me start from 1. I will say 1, 2. This first one represents X, while the second one represents Y. That means I'm starting from 2. Now that will take you to know what we will put here. I will ask myself for A, which is this Y axis. What is the highest? 4.7. 4.7 minus where I am starting from, which is 2, which is not 0 but 2. 2 all over how many space? 1, 2, 3, 4. I'm starting from where the plotting is to start. That is from here, not from here. 1, 2, 3, 4, 5, 6, 7. Divided by 7. That will be giving me 2.7 over 7. 2.7 over 7. That would be 0.386 approximately. Now, if you are using 0.386, that is 2 plus 0.386, the answer plus 0.386. You now see that this is not an appropriate number. It's not a uniform number. Now, to look for a uniform number you can use, I can decide to round it up to 0.5. Not just approximation, round up to 0.5, because 0.5 is a rounded figure such that when you use it here, you can know what you are doing. Okay, 2 plus 0.5, 2.5 plus 0.5, 3.0. You see that you can easily put it well without making much mistakes. What we mean by using appropriate scale simply means use a number that you can handle. Using this pattern, it will help you to know the closest number you can use. Whether you can use 0.1, whether you can use 1, whether you can use 2, and all have you. This is not an appropriate number. It's not a uniform number. So I'll take it to 0.5 and use it well so that it can work well. Then this is 3.5. This is 4.0. This is 4.5. Highest number is 4.7. Okay, 5.0. You can see everything is well accommodated. Then come to horizontal. We started from 1 because 1 is closest to 1.69. It's closest to it. Instead of starting from 0, which is further from 1.69, start from 1. Somebody can say, let it start from 1.5. But I decided to start from 1 to see that also by putting the scale, everything will balance well. Okay, 3.17 minus 1. 3.17 minus 1 will be giving me 2.17 all over 1, 2, 3, 4, 5, 6, 7 all over 7. 2.17 divided by 7, 0.31. Now, if I'm using 0.31, this 0.31 will be difficult for me to handle. 1.31, 2.31, 3.31, 4.31, 5.31. It might be very difficult for me because it is in 2 decimal places. Now I can say, let me take it to a simpler number. Take it up to a simpler number I can handle. This is 0.5. I can handle 0.5, and because of that, I will use it. 1 plus 0.5, 1.5. 2.0, 2.5, 3. You see how it sweets while writing it. I don't need to press calculator because I am using a simpler number I can handle. But if it is 0.31, 0.31 plus 1, 1.31 plus 1, at a point you might say, let me use calculator so that you will not make mistake. but with 0.5 it will be fluent while pronouncing it. This is 3.5. The higher is 3.17, so 3.5 I've covered it. You can see we have gotten our scale. You can now come and say, for my scale, in 2 cm represent this minus is 0.5. 0.5. Now I will not write unit. What I will write is centimeter, because unit of this is centimeter. In or on a cm axis. Then 2 cm represent 0.5 cm in b cm what axis. We have put our scale. That means your date, your title, label your Cartesian axis, then your scale. Very important for you to do it before plotting your graph. Now what you now do is 2.5 against 1.69. 2.5 against 1.69. 1.69 can fall around here. Then 3.2 against 2.17. 3.2 against 2.17. This is around here. 3.83 against 2.59. 3.83. This is 3.5. 3.83 should be around here against 2.59. Then 4.33 against 2.93. 4.70 against 3.17. So after putting your point, next is to what? Yes, we have succeeded to put our line of best fit on it. Now next thing is to put your triangle so that you get your slope. To put it, make sure that it covers at like 2/3 of your graph. Make sure that the triangle is a big enough. You know that slope of a straight line is always collinear. Yes, so whether you make it to be big or small, you will get the same slope or a close range slope, a similar slope. Yes. So we have succeeded to locate our what? Triangle. Here we'll be changing A, and here we'll be changing B. Okay? Then next thing is for us to get our what? The final value for your slope. Here is 5.5. 5.5 minus, here is 2.5, which should be giving you 3 cm. Then for here is 3.6 approximately. Then here is minus 1.6. That will be giving you 2 equal to 2 cm. We are using approximated answer from the graph because we are using a sketch of the graph, not the real standard wire graph. So what you will do is that you now say slope equals to change in A over change in B, and that will be 3 cm all over 2 cm. That will be giving you 1.5. This is the refractive index of this graph. Prism. Yes. So we have been able to get it. Remember we said it has a range. That the range is 1.46 to 1.54. Answer we got falls in the range, so we'll mark it good. Now we have gotten the slope. Estimate the error in the slope. Wow. In this, only one point is very close to the line but not on the line. So that one point that is very close to the line, I will put my ruler on it. I will put my ruler on it such that I can get a line that will be parallel to the line of best fit. So look at the point and look at the line that is parallel to line of best fit. So what I will now do is that once I put the line, I will now put the ruler vertical. I'll put the ruler vertical, so I am to get this point. And also get this point. I can call this is 3.5, this is 3. This is 3, 3.1, 3.2, 3.3, 3.4. This is 3, 3.1, 3.2, 3.3, 3.4. 3.1, 3.2, 3.3, 3.4, then 3.5. So I can take here to be 3.4, take here to be 3.3. Now, error in the slope SG equals to 4W over NR, where your W is your vertical scatter, which you get from putting your ruler parallel to your line of best fit and locate it to that point that didn't enter in the line. If they are two, when you put this parallel line, you also put the other one, the same parallel to the line of best fit. That is, if they are two, look at your line of best fit, this line fell out, this point fell out. What you do is you draw a parallel line, then use your ruler, place it vertical and what? Connect it. Take the value, subtract. That is what we mean by vertical scatter. This is what we call vertical scatter, W. But if it is only one point that fell out, put only one parallel line, then what you now do, put your ruler and get a perfect vertical line. Take this value, that is it. Then this minus this, you get it. So with that, 4 times W will now be 3.4 minus 3.3. That is 0.1. 3.4 minus 3.3. That is 0.1. All over n means how many points do we plot? 1, 2, 3, 4, 5. 5 points. Arrow means your horizontal minus this minus this. Then you start having 3.17 minus 1.69. 3.17 minus 1.69. That is 1.8. I will write 1.8. 1.48. So the arrow means range of the horizontal, the highest minus the lowest, you write. Then N means the number of points you plotted. 4 is constant. W means your vertical scatter. You now get the value. The value will be 4 times 0.1 divided by bracket 5 times 1.48. That will be giving you 0.054. 0.054. No unit. Refractive index of a glass has no unit. That means our slope is 1.50 plus or minus 0.054. 1.50 plus or minus 0.054. That is how to package your slope. Okay? Now we have gotten our slope and we have gotten error in the slope. They said state what physical quantity A represents. From your Snell's law said that sine I over sine R will give you refractive index. Now from this experiment, you notice that it is A over B. Change in A or over change in B will give you refractive index. That means that A is equivalent to sine of incidence. A is equivalent to sine of incidence. A is equivalent to what? Sine I. Yes, that is sine of angle of incidence. That is what A is equivalent. That is the physical quantity it represents.